Hi everyone, welcome to IT and Automation and to our Kubernetes tutorial series. In today's video, we will deep dive into how Kubernetes makes the scheduling decisions based on resource requirements. So if you're following us, you must have seen. If not, please check out our videos around scheduling decisions. This is most likely the fourth in the series. Back to the topic. Understanding resource requirements is crucial for optimizing the performance and efficiency. And in previously, if we have to touch upon the previous videos around scheduling decision, we have done around pod disruption budget, pod priorities, node affinity, anti-affinity, and today around this resource requirements. So without further ado, let's look into resource request and limits. So resource request and limits are, as I said before, quite essential for managing the resource your pod can consume. So what do? Is they ensure that your application gets the necessary and appropriate CPU and memory and prevents that any single pod from monopolizing the resources. So there is two key concepts here, right? Resource request and resource limit. What does request do is they are the baseline. So it is a minimum amount of CPU and memory that a pod needs to run. So in Kubernetes cluster, Kubernetes scheduler uses these values to make a decision on which node has enough available resources so that it can place that newly requested pod in that specific node. So as you see in the screen, this particular kind pod has a request of memory and CPU. It's requesting MIB of 64 maybe bits MIB. The unit is in binary system 1048. If I can avoid that 3 digit in the end, this is maybe bit symbol MIB. So in this example, the pod requests 64 maybe bits of memory and 250 milli CPU, ensuring that the pod is scheduled on the node that can actually meet these requirements. Scheduler does that decision based on the availability in the node. There may be other aspects around this auto scaling whenever the node resources are not enough, but that is not thing that we are going to cover in this particular video. So next topic is resource limit. We talked about the baseline, and now we are looking into the ceiling side of things. The resource limit, as opposed to resource request, specifies the maximum amount of CPU and memory a pod can use. This helps prevent a pod from using more than its fair share of resources. So in this particular manifest there, the limit is 128 and CPU is 500. So this particular pod has a limited memory of 128 maybe bits and 500 milli CPU. If it bursts above that, it will be choking. It will flat out on the CPU side of things, and then if it hits that memory ceiling, it will OM and cause the out of memory and restart the pod. So how does this scheduler use these resource requirements then? We slightly touched upon that, but now let's talk a bit more. So as we understood what is request and limits for the resource, so how does Kubernetes scheduler use this? When a pod is created, scheduler checks the resource request against the available resource on each node. You have the manifest which says I need this amount of resource, and Kubernetes knows what nodes it has got in hand and what is the allocatable resource in the node. And it will choose the right node to fit those pods based on what you have requested. And that is going to be based on request, not the limits. That is something to keep in mind. It is not just the resource request that it needs to satisfy. There are other things as well. You may want to visit node affinity, anti-affinity video. It also depends on the taints side of things as well. So not covering that. Please go and check our other video around node affinity for more details. So as in this diagram, you see the scheduler evaluating the nodes to find the best fit for the new pod and based on its resource request. That is the part around resource request and limits, but Kubernetes also allows you to overcommit. So you have a request, which is what Kubernetes bases on, and you have a limit side of things, right? In this example, you have a pod which is requesting 32 megabits of memory and 100 milli CPU, but it is allowed to use up to 256 of memory and 1 CPU. That is allowing you to utilize the node resources as well as allowing containers or pods to burst at the times. This approach will lead to a higher utilization and also can risk into resource contention. But again, there are benefits around like being useful for maximizing the resources. Talking about resources, again, there is other aspects to it as well, quotas and limit range. To manage resources, Kubernetes provides a resource quota and limit range. These are at the namespace layer. Resource quota limit the total amount of resources that the namespace can use, while limit range set minimum and maximum values of resources request and limit within the namespace. So in this case, example namespace collectively don't exceed 1 CPU and 1 gig of memory in the request and 2 and 2 on the limits. So that is something you're controlling around the whole namespace. Whereas you can also use the default request as in that example there, where you can say, I want a fair distribution across the pods within the namespace. In some cases, this can be useful. And let's consider a real world example, real world scenario here. Suppose you have a cluster running various microservices. Some services are critical and require guarantees resources, while others are less critical. You can also use pod priorities side of things, which we have covered in the previous videos. But let's talk from limits and request perspective here. So by setting appropriate requests and limits, you ensure that critical service always has the resource they need. So in this example, we are allocating more requests on the critical and less on the non-critical, as well as the limit can go as high as 500, whereas the critical one can go as high as 1 CPU, similar on the memory. So this setup essentially means the critical service is guaranteed more resource and it will always perform better, right, or optimally, hypothesis here, while the non-critical service is allowed to use resources flexibly within the defined limits. So yeah, to conclude, that's a wrap on resource requirements in a Kubernetes scheduling decision. And by properly defining resource request and limits and using the resource quota and limit range, you can ensure the efficient and fair resource allocation across the cluster. And not to forget, with the node affinity, anti-affinity, pod affinity, anti-affinity, pod priorities, disruption budgets, all combining together, you can have a really efficient management of your cluster. that was pretty much it for today, and see you soon.